Hello everyone, and welcome to the fourth edition of Winter Data and AI Meetup. Thank you for joining us today. Today is the last day of our conference, and today we will talk about a different way of creating presentations. Instead of normal slides, the session shows how AI and code can help build interactive presentations with live data and visualizations. Our speaker will show how modern tools and AI can generate presentation code and how this approach can make presentations more flexible and easier to maintain. If you work with AI and often present your results like on demo sessions or on such talks, this session should give you some useful ideas. So if you enjoy this event, please like and subscribe to support our community. Your feedback helps us to create such meetups. If you have any questions, please write them into the chat and we will discuss them with the speaker after the talk. And now let's welcome our speaker. So Alexander, floor is yours.
Thank you, Alexander, for your introduction. It's my pleasure and an honor to give a talk within this community at Winter Data Meetup. So my name is Alexander. I'm a data scientist at EPAM, and I've spent pretty many years in academia giving talks as well, both data-driven and non-data-driven. So I would like to share my experience and my current process for preparing such talks, and hopefully it will inspire many of you to transition from PowerPoint into something, more interactive. So let's start with the motivation of this transitioning. So I assume that we are mostly, data guys who have gathered here. So data engineers, data scientists, data analysts, and specifically for us, what do our bread and butter presentations may look like? So they are often data-driven. We need to show numbers. And to show numbers visually, we create charts and diagrams as well to show the structure of some systems. These are the main points. But we often also would like to demo some things, like Gradio or Streamlit demos showcasing our models or a POC of our services. But the standard elements that are the core of any slide deck still, of course, are used often. So text-based talks are still valid. What does our typical environment where we work looks like? So we work with code pretty often. We process data using code in Python, in Jupyter notebooks. We work with code repos. And we perform data analysis and visualization using code as well. But we have still to prepare slide decks to give talks. And the pain points here are the following. So we have to switch between the coding mode, kind of sitting in an IDE like VS Code, and PowerPoint mode, where we have to point and click. And we often have to copy-paste our charts that we have created elsewhere into our slide decks to make it happen. We have to switch between our slide deck and, say, a Gradio app when we are presenting a demo of our POC. And one of the cool things of modern days, like LLMs, are of limited use within the point-and-click software like PowerPoint. Well, it gradually gets better, but it's not yet there. And so imagine the following. Imagine using a well-structured code to create your slide decks without leaving your IDE. Imagine being able to integrate the charts that you produce in Jupyter directly into your decks and being able to show demos right inside your deck without switching apps. You can use all your familiar IDE features and version control systems to version your slide decks. And you have all the power of LLMs that you currently use either through chat-based systems or many of you, I'm sure, are using Claude Code or other agentic tools. You can use that to actually create your slide decks. And this is exactly why you may want to transition to using HTML slideshow frameworks. Your deck, in this case, is essentially just a web page. But although it's a web page technically, it still looks like a normal, familiar deck for your audience. They may not even know that it's not a PowerPoint slide deck. And everything that can be rendered in your browser can be included in your slide deck, as it is now a web page. Your code stays readable and organized because it is HTML, so it's highly structured and semantic. And the tech that allows you to craft such slide decks is pretty mature, so it is being developed since 2013. And one of the major frameworks that I'm showcasing in this presentation is Reveal.js. This is a very well-developed framework with lots of plugins and features. So LLMs are just great to help us with creating slide decks in this format because they are text native. Yes, there are many multimodal LLMs nowadays that are able to generate images and understand images, but still the text is the native modality, the main modality, the strongest modality of LLMs. And LLMs, while they were trained, they have been shown lots and lots and lots of internet data, and it is already often in HTML, CSS, and JS. So LLMs will be great at understanding the structure of our decks. Also, some other elements that we will include in our decks are actually also text-based formats. So what I'm going to showcase later are some charts that are stored not as raster images like JPEGs or PNGs, but rather specifications in JSONs and XML. And both of these formats are text-based and can be directly tweaked by LLMs. So let's start with the basics of Reveal.js framework. Well, as I've said, our slide deck is basically an HTML file. An HTML file is based on tags, HTML tags. And there is a heading portion of our file, which you usually just copy-paste between your presentations. It contains the links to your styling systems. And, well, normally you just don't touch it. So you copy-paste it between your decks. So I'm going to just leave it as is for the head and go on to the body. The body is the actual workhorse of your HTML. It contains the content of your slides. And your slides are going to be wrapped in section tags. So your code is going to be very well organized. After that, you include a script for loading the Reveal.js core engine. And you call the initialization command to load some plugins, tweak some settings. The initialization command looks like this and also can be copied between all your decks as soon as you come up with some standard way of organizing your deck and find your own combination of your favorite parameters. Things like slide dimensions and whether you want to show slide number or not, and whether you would like to have extra margins, etc., they are controllable here. Now, a single slide in Reveal.js is going to look like this. So it is wrapped, as we said, between the section tags, the opening tag and the closing tag. And many tags in HTML, they have not just the name of the tag, but they also have attributes. And attributes, they play one of the key roles in frameworks like this. They allow you to adjust your slides and individual elements on the slides. So this is an example of an actual slide from this talk, the About Me slide. And this slide was using a template for a slide, which I called About Me. The styling for this template is stored elsewhere in a CSS file. And the elements of this, the text elements that are to be included are what we can actually see here. So we can see the image of the portrait, we can see the name, we can see the biography heading and the biography itself. And although it may look, and it is actually more verbose than just having this text without any wrappers, but at the same time, it is more semantic because you can clearly see what semantic role a particular text element is playing on the slide, if you name your styling classes in a semantic way as well. So this is just a single slide of a talk. And you create different templates for different slides, and then you can reference these templates using the class attribute here. By the way, this is another attribute which is used to show the slide heading or something like a heading in the left menu of the deck. This is an example of a workhorse type of slide where you have just a heading and an unordered list of elements. And here is when we see one of the main workhorse attributes of Reveal.js, the fragment attribute. Like the next thing you would like to do, like after you split your content into manageable chunks that we call slides, right? We can also split the content within the slides into different portions that we'd like to show to our audience gradually on click or on key press. And as soon as you'd like to highlight something or show something on key press, you wrap it in some tag, well, necessary tag, with adding a class element with fragment. So fragments in Reveal.js are keys to showing your elements on demand, on click, or highlighting them on demand. So I have another image here, the panda image, and these pandas are going to be throughout the talk. And this is something that you should remember, right? So each slide is a section in terms of HTML, and each piece of content that you'd like to show on click gradually is a fragment. Okay, so let's start with actual fun and see what we can do with all that stuff. Well, first, let's start with embedding demos. This is an example of a Gradio-based demo from Hugging Face embedded directly into our presentation. So suppose we have created or tweaked some chatbot model, and we'd like to highlight like its key features to our audience. So then we can just directly integrate the chat bot into our presentation. So how do we do that? Well, we employ a feature of HTML, which is called an iframe. So an iframe is essentially a web page is inside a web page. And as now all our deck is a web page, we can insert another web page here with a single line of code, essentially, by providing the source URL for this page and the dimensions. So this is actually the complete code for a slide like this, like the one we've just seen. Okay, that's as simple as that, and you have a demo integrated in your slide. Now let's go to presenting actual numeric data. So the simplest way to present data is to show a table. It's not yet a graphical way to present, but it is a very common way to present numbers. So tables do not have to be boring as soon as you have transitioned from PowerPoint to Reveal.js. You can create a table like this, and it will be sortable by any of the parameters you want. But you can still predefine some animations, well, not exactly an animation, but rather predefine some highlighting that you would like to do during your talk. And here I can highlight like one metric for one LLM, then another metric here, and then another one. So this is all doable. And at the same time, it's not static. I can still reorder everything, so everything is kept dynamic and tweakable right at the moment when you are giving your talk. How does it look like in code? Well, a table in HTML is a pretty verbose structure. So you have a table tag, you have a heading of the table, you have a body of the table, and you have to wrap like everything that you show in specific tags. And as you want to highlight something, you will have to add highlighting classes to this element. But, well, thanks God, you do not have to do it manually. So what we can do instead, if you work in Python, and many of us do work with data in Python, you are probably using a library like pandas. You keep your data in data frames, and this is the original data. And so what I did here, I just created a small script, well, rather not created myself, but asked an LLM to create that by telling it that I have a data frame like this, and please do the following. Please convert it, like make a script that converts it into HTML table, adding specific classes, like fragmentation classes, to the maximas in columns. That's exactly what you have seen at the previous slide. And the LLM has produced me with this elaborate script. So I just ran the script, and it produced me an HTML table, which I didn't copy-paste anywhere. I just included this table with a single line of code, essentially. So in Reveal, we can include the HTML portions of our presentation instead of directly, pasting them in line into the HTML code of the whole slide deck. It makes our slide deck decomposable and very easy to maintain. So you still keep your data and transformations in Jupyter if you want. You regenerate HTML tables for your slide deck if anything changes about your data, and you have it readily available at the moment when you are giving your talk. Now let's come to the graphical element, to the charts. So there are numerous chart libraries, and I assume that we are mostly working with Python. And for Python, there are, of course, dozens of libraries, but most famous are the following. So Matplotlib, it is historically the first major visualization library for Python. And it has its own thin wrappers, Seaborn and Plot9. Plot9 is based on our package ggplot2 syntax, so it will be pretty handy for people who have some R and ggplot background. But I specifically would like to concentrate on the other three libraries, on Vega Altair and Plotly and Bokeh, because these three, they can create genuinely interactive charts. So Seaborn, Matplotlib, and actually any wrapper of Matplotlib are able to create static charts, like pictures. But to enable interactivity, you have to go on and use one of the top three libraries. My favorite one is Vega Altair. So this is some library which I use like almost daily. What are the advantages of Vega Altair? Well, it creates interactive visualizations. And this library has a highly declarative style. So you do not have to, encode in Python what exact transformation you have to apply to your data to convert it into coordinates of some points on some canvas so that it looks good on chart. Instead, you basically define a mapping. So I want to map this data attribute to this graphical attribute, to color or to position, to X coordinate or to Y coordinate. And the library itself decides automatically how to perform the mapping. You do not have to write lots of formulas to make it beautiful. And the third advantage here is that this library produces not static images like PNG that are hard to tweak, but it produces actually JSON specifications for your charts. I will show you an example of such specification a bit later. So this library is capable of producing a wide variety of charts that are shown here. So you are not limited to only basics. You can produce beautifully looking interactive charts by using this library alone. Here's a minimal example of a code in Altair. So you import the library, you import a sample data set of cars, and this is the complete code. It's not abbreviated. It's not dumbed down. It's the complete code used to produce a chart. So we create a chart based on some data set. We provide the main mark for the chart. So what's going to be the main kind of carrier of the meaning. For scatter plots, these are just points. And then we provide the encoding for the data. We want to encode horsepower of the cars by the X coordinates of the points. We'd like to encode miles per gallon as the Y coordinates of the points. And the origin country of the car is going to be encoded with color. Then you use one single command to make the chart interactive and save it to a file, which I specifically note is JSON file, not a PNG or JPEG file. And this chart is interactive already, so you can zoom in and out, you can pan this chart. So that's it. How do you include this chart in the data in your presentation? Well, the file that Altair is going to produce is a Vega Lite JSON specification. This is a JSON file where you will see pretty much the same stuff that you've written in Python, but in a more verbose fashion. Some things are going to be like new and you do not have to read through them. So for instance, a parameter here is something that was added automatically because we required our chart to be interactive. And note that the complete data set is also here. So the data set is engraved into the chart specification itself because it is essentially the only way to make the chart interactive. You have to keep the original data because it has to be constantly transformed and tweaked when you are changing the view of your chart. And you include charts like this in your deck by creating a single div with this magic attribute, data vega, which points to the file, to the JSON spec file that you've created in Python. So again, you do not hard code anything in your slide deck. You keep all your charts separately, just as if they were images and you inserted them using image tag. And it's there, it's in your slide deck, ready to use. You do not have to resort to just basic interactivity. So here is an example of another kind of interactivity where you can use the mouse hover to display like exact values for 3 lines here on this line graph. Or even more advanced example of interactivity where you can actually have 2 charts which are interlinked between one another. So when I brush anything on the left, I compute automatically the aggregation on the right here. And if I click something on the right, like this, you can see that the corresponding subset of data is highlighted on the left. So I can clearly see the Pareto border here, the outliers, if there are any, and so on and so forth. So this is also like an Altair chart, essentially, which is no longer a chart, but already a micro dashboard. Okay, so here is an example of a code for this micro dashboard. I will not spend too much time on that. So you just have this time to create your own interaction handlers and create 2 different charts, the scatter plot by including the interaction handler and bar charts using different kind of mark, the bar, and include its own interaction handler. And still the whole description is pretty declarative. So you just specify the encoding and specify like on which conditions provided by your interactive handlers you highlight your elements. For instance, you mark all the points on the scatter plot as gray if they are not included into the subset of categories provided by the parameter, or otherwise you use customer segment data attribute to choose a color automatically for these points. And you are done. You concatenate the charts horizontally and save them into a JSON-lite spec file. That's it. So other libraries also are capable of producing interactive charts, like Plotly is a very popular library, which is able to produce even animated charts. So this is an example of an Gapminder, famous Gapminder animation by Hans Rosling originally, included as an integrated Plotly chart into this slide deck. So we can go back and forth. The interactivity elements are still available, like tooltips. A great example of a rich and animated chart. Another famous library, well, nowadays I'm not sure it is used as extensively, but still, bokeh, which allows you to at least to zoom and pan, so basic interactivity for bokeh charts is available. And I'm showing it, not to just show like yet another type of library whose charts you are able to include on your slides, but to show that if you'd like to support any new library that you use, it's actually simple. I didn't have a plugin that would allow me to include bokeh charts into my deck, but I asked an LLM to do so. Here is a prompt. So I just pasted the existing code of a plugin that I had to include Vega-Lite Altair charts, and I showed it the type of HTML produced by bokeh. Bokeh produces HTML pages. And I asked, okay, so can you please advise me on how to create code for a plugin which will be similarly used to integrate bokeh charts directly into my Reveal.js slide decks. And the LLM provided me with a complete instruction and the code of a plugin that I used to integrate bokeh chart for this particular talk. I didn't have such plugin before. Now let's complete our chart section with a note on non-interactive charts. What if you still use Matplotlib? If you still use Seaborn, a very popular library for statistical visualization? These libraries, Matplotlib and any of its wrappers, they are not capable of producing like purely interactive charts, like genuinely interactive charts, but they are still able to produce SVGs. And I advise you to save your files in SVGs, not in, say, JPEGs or PNGs, if you would like to support interactivity, like at least some kind of semi-interactivity, pseudo-interactivity. Because in this case, I will be able to at least do the following. I have a scatter plot, and I can show like groups of points corresponding to different categories on click. And this is one of the things that you most often do. You would like to show something on click, not to reveal all your secrets of your slide like in advance to your audience, but to make it focused. So what is the code to make it happen? Well, I originally just had a Seaborn plot. Like this is a standard code to plot a Seaborn chart. But I saved it as an SVG chart. And SVG is a format that uses XML, which is pretty similar to HTML. So you still have tags, but these tags describe not textual elements, but rather graphical elements, individual points, curves, lines, rectangles. And these elements do not are not baked into your canvas. They are still tweakable. So I saved the chart as an SVG. And then I reopened the chart with another script that assigns different fragmentation classes. So recall that Reveal.js needs you to assign fragmentation class to elements for them to appear on click on your slide. And this code thus makes me an SVG, which behaves in a proper way when inserted into a Reveal.js slide deck. So now my elements of specific color, they appear at specific moment of time. And this script is pretty reusable. So whenever I have a different kind of chart, I can specify the palette, and I can assign, still these fragmentation classes to elements having specific color in my chart. I didn't code this script myself. I used an LLM. So how did I do that? My prompt looks like this. So I have pasted the code that I used to plot my scatter plot, just a standard, Seaborn code. And then I opened the SVG in a text editor. SVG is a text format. It can be opened in a text editor. I found like what elements have this color that I used, and I have shown them to an LLM. I've pasted this element to an LLM, and I asked, well, I want this element to be assigned a specific class like this. And I want to do it programmatically. I don't want you to do it like, ad hoc. I want you to create a script that will be reusable and allow me to do the same kind of transformation for like in future for new charts. And LLM has produced the script that you've seen on the previous slide. Okay, so now that we have covered different libraries, and now that you probably believe that it is pretty easy to ask an LLM to produce a Python code for a particular kind of chart, or to tweak that chart later before inserting into your slide deck, maybe you would like to revisit some of the less frequently used kinds of charts. So this is my advice. So if you only are using like bar plots and scatter plots all day long and line charts, well, maybe just think out of curiosity if you can choose some other types of charts occasionally to keep your audience like interested. One of the libraries that contains code snippets and description of chart types and use cases for those charts is pythongraphgallery.com by famous visualization expert Jan Holtz. So I highly recommend this catalog, and it will provide you with most common chart types as well as Python code examples for them. Of course, you do not have to use like some weird chart type just because you can technically. You have to choose it based on the data type that you have and the type of question that you have for your data. What would you like to reveal about your data? And thus, you may want to use one of the chart choosing decision trees like this. So it will help you choose between those numerous chart types based on the kind of data that you are analyzing and or showing to your audience, highlighting some patterns and the kind of patterns and questions you are dealing with. And this is an example of a decision tree from data2viz.com. So now let's go through from charts to diagrams. Diagrams are not based on numbers, but they still show structure, and they are very often used in slide decks. I would like to showcase Mermaid.js diagramming library. It's a mature diagramming library supporting great variety of diagram types. It has declarative markdown syntax. So again, something which LLMs love, something that looks like markdown, something that looks like text, like HTML. And this library produces SVG objects. So even after diagrams are rendered, they can be tweaked using LLMs. That's very important. So I'm not going to show you all the examples of these chart types. Let's start with the simplest chart type and the workhorse chart type, the flow chart. So when you are creating charts in Mermaid, you can enrich them with some animation, highlighting, showing elements of your diagrams on click at specific moments of time, highlighting some elements like this. Okay, and how do you do so? Well, the code for the diagram that you've just seen on the previous slide is this one. So the diagram itself, without any kind of animation or highlighting, is just these 4 lines of code. It's very declarative, which is great. It means that your definitions of the diagrams will be relatively short and simple to grasp. This whole part of the code is for showing parts of the diagram on click. I didn't code this myself. I used an LLM. Okay, so how? Before I show you that, I'm going to show you just a couple of use cases before. So architecture diagrams are also possible in Mermaid.js. When you are speaking about some parts of your system, you would like to highlight an element while you are talking about it. It's not intrusive, but it's still focusing your audience on like what you are talking at this specific moment. And that's how you can do it on an architecture diagram. And this is an example of a more complex, large diagram of a RAG system in AWS architecture, where you can show parts of your diagram at different moments of time and explain like about the interactions. So for instance, the similarity search goes here, and then the vectors goes there, and you return the response to the user. So you are not, overloading your audience with the whole diagram at once. You show it, part by part. So to make it happen, I have created a pretty elaborate prompt for an LLM. But the good news is that the major part of the prompt is reusable. So I just provided the LLM with a description of how Mermaid diagrams enriched with specific, class application, fragmentation class applications, how they are structured. I have gone into great detail for the LLM to understand like how an example of such diagram would look like, what will happen, so how it should behave, etc., etc. So this part of the prompt is long, but it's reusable. This was the genuinely new part of the prompt, where I asked LLM to essentially to produce it end to end. So I've asked it to first produce me the Mermaid code for the diagram. So kind of this part of the code, okay? And then I have compiled the code into an SVG. LLM cannot do it for me unless it is an agentic tool like, say, Claude Code. And then I have pasted the SVG into the chat back and asked an LLM to produce this part of the code, which has to have information about how your SVG elements actually correspond to the original declarative code in your diagram. So that's it. LLM has produced the diagram that you saw on the previous slide end to end. Okay, so as our slide deck is now a code base, essentially, of course, we should stick to the best development practices to make our experience fun instead of making it painful. You may want to keep your HTML tidy. So part of that is splitting your HTML files into pieces. Do not paste tables or charts specifications directly into your code. Keep them as separate files. You can even keep parts of your slide deck in separate HTML files. So this is how the root HTML for this very talk that I'm giving to you right now, how it is structured. It has lots of separate HTMLs. The directory structure for your project may look like this. You have a root entry point, index.html. You have plugins that you are using for this deck. You have images where I suggest you split them into template media, slide backgrounds, for instance, or reusable elements that will come from talk to talk, and some ad hoc, case-specific images like pandas, for instance, this guy here. And you also have CSS, much of which is reusable. So classes, like how your headings should look like, how you should highlight elements, fragments on your slides, etc. And lastly, well, last but not least, you have the content, the text content of your presentation in a separate folder or in the root. You can place it there. One of the key, I would say, benefits of using code-based frameworks is your ability to version control your code properly. If you use a VCS like Git or a similar one, you will be able to not just version your slide deck, but also, say, keep different versions of your slide deck for different types of audiences. For instance, in one kind of slide deck, you will include that section or that chapter. In another version of that slide deck, you are not going to include this chapter. In a different version, you are going to have a bit different design. That's different CSS files, but the same content, actually, for dark theme or for light theme. And you can work on these parts of your slide deck independently and keep them all in VCS. By the way, this diagram is built in Mermaid.js. So yet another showcasing here. As in any kind of coding endeavor, you would want to use reusable solutions over ad hoc solutions. So, of course, you can, for instance, take an SVG for a chart, paste it to an LLM, and ask it to tweak. But as we have seen already, instead, it is better to ask an LLM for a reusable script that you basically take once and then can apply in all the situations when you need to do practically the same thing to your SVG, say, highlight something of particular color on click. Semantic markup is better than ad hoc markup by the same kind of logic. So when you have some element that you want to highlight stylistically, like a heading, you, of course, can inline the style. I want this font size. I want my heading to be bolded, etc., etc. But if you can see that you can reuse them and you would want to reuse them when you are giving multiple talks, you better create a single template for this kind of element. So a super important heading, you code the style once, and then you just use it, you reference this style by applying a class attribute to your heading. This looks more semantic, and this is just easier to code once you have it stored somewhere. And of course, you do not store your styles in the HTML file with your content. You use CSS files for that, and CSS files, they travel with you like through all your future talks. You do not have to reinvent the wheel each time. So speaking of not reinventing the wheel, there are numerous plugins existing already for Reveal.js. And instead of even, well, nowadays it is easy to ask an LLM to code you something, you may want to reuse one of the existing plugins for Reveal, just including this plugin in your Reveal initialization script. So just if you are going to learn how Reveal.js works, I suggest that you look for the current ecosystem of Reveal.js plugins as well. Lots of things are readily available. Okay, so having a good, convenient IDE turns the process of slide deck development into pleasure instead of being painful. And VS Code is a de facto standard free IDE for web development nowadays, and it is capable of providing you with a preview of your slide deck, because your slide deck is just a web page. So you can open this web page with your slide deck alongside your code. And this is pretty similar to a genuine what you see is what you get experience. So the same can be said about diagrams, at least some diagrams. Like for Altair, for Vega Lite specifications, you have an online Vega editor where you can tweak the spec on the left and immediately see how it will be rendered on the right. The same for Mermaid. There is an online Mermaid diagram editor. It does not support all that animation kind of stuff, but at least you will statically see the resulting Mermaid diagram when you are tweaking things about it, like adding nodes, working on the structure of the diagram. And then you will once your diagram is ready, you will call an LLM once to actually animate parts of it. There are numerous other tools that will simplify your life. So HTML actually doesn't just look verbose. It is a verbose markup language. But you do not have to code in plain HTML. There is a tool called Emmet. This is a notation when you write a short line of code, press Tab, and you basically get immediately a nested, nicely looking structure of an HTML list, for instance, in this case, a list with 3 elements that you directly populate with the actual meaningful text content that you like. In this way, you do not think about this verbosity of the markup, you do not suffer from that, but you just think about the actual content. How do we migrate from PowerPoint? Clearly, we have to learn how to do that. Well, actually, what we need to know is that PowerPoint presentations are actually not black boxes. Nowadays, they are just archives. If you change the extension of your PowerPoint deck into zip, you can open it with an archiver, and you will see the images, the structure of your slides as XML code in this archive. Everything is accessible like this. I also suggest you export your PowerPoint slide deck as a PDF, and then you will be able to paste this thing into LLMs. LLMs are great at processing PDFs, understanding visual structure of the PDFs, and then you can ask an LLM to produce you with at least the blueprint for your talk, assuming that the original talk is in PowerPoint. So it will help you greatly transition from PowerPoint to this kind of Reveal.js or other framework. The compromises are there, but I think they can be actually treated as benefits of Reveal.js. We embrace consistency over micromanaging point-and-click slide design. We have to embrace transparency of our code that we can see right away, instead of what you see is what you get, without being able to see the animations, for instance, how they are architectured. We embrace open source tools over proprietary Microsoft ecosystem. And if you are ready to embrace those things, you can jump into these waters. So what have we covered? We have covered the basics of HTML, CSS, JS frameworks, specifically Reveal.js. We have covered embedding rich interactive elements, which is one of the key advantages of having the full-blown, in-browser experience instead of dedicated slide deck design software. And we have covered, to some extent, the development practices for your decks that will make this process not painful, but fun for you. And lastly, we have covered transitioning from PowerPoint. The resources that you will have access to after this talk are here, so please do visit those links. You can access an example talk similar to the one that I'm giving right now in Reveal.js, Altair, Mermaid. So I suggest you having a look at these resources. And now it's time for Q&A. Thank you very much for your attention.
Thank you very much, Alex, for interesting project and like a new view on this popular problem. Yeah, we
Thank you.
have some questions. What made you think slides are broken? I need to do something different.
Well, the main thing that bugged me is that first of all, I started using Altair instead of Matplotlib or um, Seaborn. I used to teach a course on data visualization when I still worked in academia, and I was fascinated by like how many possibilities you have for interactivity and beautifully looking charts instead of just having boring charts. And then when I was exposed first to Reveal.js, I thought that, okay, so that's exactly the thing that we need to be able to include interactive charts and interactive tables into our talks. And then I started noticing many benefits, advantages of using Reveal. So for instance, being able to animate like textual content on the slide as well in the way that I like. For instance, try doing this like natively in PowerPoint, like things like highlighting specific elements. Let me bring the menu. So highlighting specific elements with underlines. So things like, yeah, so like underlining. Well,
Mm-hmm.
things like having an element to dim after you go to another element. So things like that, like dimming one phrase when you go to the other phrase, so that at each moment of time, the audience clearly sees on the slide, like what exactly you are talking about at this very moment. The audience is not going to, think about what is important on the slide at this very moment. These things are very easy to do in Reveal.js once you get accustomed to that, but they are really, really hard to properly and quickly do in PowerPoint unless you, I don't know, script maybe there as well. So you will have to use probably scripts to make it happen there
Mm-hmm.
automatically.
Yeah,
Yep.
you described different charts, but what about, for example, diagrams? I don't know, like AWS diagram, is it possible to include in similar way?
So AWS diagrams, well, we have an example of an architecture diagram here. So
Great.
these kind of diagrams, they are possible, and all the icons are here, as you can see. So AWS icon set. Of course, at some moments, you may bump into limitations, but then you will probably find a solution by coding a plugin if you really need to.
Okay, next question. So it's a great approach, but when it's not a good idea to use?
This is not a good idea if you have never coded in HTML and you are looking at this kind of way of working with things for the very first time, and you need to have your slide deck ready in a couple of hours. Other than that, I would say, well, your slide deck may load for longer than in PowerPoint. So in PowerPoint, you press F5, you immediately pretty much have your slide deck on screen. So if you have a slide deck in Reveal.js and you are using a lot of plugins, like I'm doing, well, this slide deck is going to take like approximately 10 to 15 seconds to load completely as a web page. On the other hand, I can be sure that you normally do not have like as many slides, like almost all of which are interactive. So you are not going to have nearly as many slides as you would like. And as you can see, like one of the points that I want to highlight is that this diagram, like if you just look at this slide, you will not notice that it's a web page. It's indistinguishable from a normal slide in PowerPoint. So for instance, I wouldn't say that, okay, Reveal.js does not allow you to tweak slide design properly. It does allow you to tweak slide design properly. You are able to convert your corporate template for your decks to Reveal.js and then reuse it for all your subsequent talks.
Yeah, one more question. How do you think, would it be possible to create such presentations or engine without AI? And how long would it take?
It will take longer than when using AI, but nowadays, this is a very large, of course, presentation with lots of separate elements that I had to tweak here. But normally, these are some standard elements which you code in HTML. You pretty quickly get accustomed to the HTML structure, and finally, you can use proper tools, like Emmet, to speed up just writing HTML code, and you can use things like VS Code to see what you are doing, not just blindly, coding something without having the results next to it.
Yeah, these presentations look really like yeah, you look really great, and but is not it like do you know if there are any ready-to-use solutions already? Maybe some PowerPoint alternatives that already can do something like that? Have you tried to research?
I'm not sure like anything, like any existing solution can be as tweakable as this one, right? So I didn't have a bokeh integration. I asked an LLM and I had a bokeh chart integration in like 10, 15 minutes. So I couldn't do it whenever like existing SaaS tool or, local tool like PowerPoint, if I had a tool like this. Definitely not as tweakable. And like I get back to the one of the main advantages to my viewpoint. So I think that being able to properly version control your slide deck is very important thing to do. And I got used to this, so I cannot get back to PowerPoint for complex talks that I may want to reuse later.
We have several more questions. How often do you need graphs interactivity in presentations, even if it's technically possible? As for my experience, I'm trying to eliminate animation in most of cases because it lower attention.
Absolutely. So I totally get this question. So it is one of the major, advices that is given in various books that you wouldn't want to use all the technical stuff that you have. You wouldn't want to use animation on your slides. But one of the key things here is like first, this table is not animated. It doesn't distract the audience in any way. But if somebody asks you a question, like, and what, like, can we have a look at like which model is best specifically under human eval and what is the ranking? You have a click and you have the ranking immediately on this slide. You do not have to do anything extra. This is not an animation. This is an ability to tweak the presentation on this slide on your audience's demand. Okay, the same goes for charts. So I think that this chart, like if we have an example of a really advanced chart, like with this micro dashboard. Again, it is not animated. So this micro dashboard is just essentially a collection of two static charts, right? So you do not have to click on any of them. But if you want, if you feel like that during your talk, you can easily do that. So one other advantage here is that you can keep your charts separately from your slide deck. So this is one of the key things for me, key advantages. I do not use animation that often when I prepare normal like presentations for the client, but I just have a Jupyter notebook. I have all my research there, exploratory data analysis there, but I have commands there that do not harm anything, that export my data in these kind of files. And I know that I can include with a single line of code any such chart in my slide deck. And if my data changes, I can just rerun my Jupyter notebook and start my slide deck, and the data will be updated automatically. I do not have to copy paste anything between PowerPoint and my EDA environment, which is Jupyter.
We have several similar questions. So, is it possible to export this presentation in PowerPoint or PDF format? Because many customers often require a static version.
Absolutely. So I think we have a PDF version of this deck on the page of this talk, right?
Not yet. It will be shared. Yeah, later.
Okay, yeah. So Reveal.js allows you, but like when you think about like normal things that PowerPoint allows you to do, export as PDF. You have that in Reveal.js. You essentially like what you have to do that. You just go to your URL of your deck. It is running locally for me right now. So and add a parameter print-pdf. It is going to open the page in the mode which allows printing. You are going to press Control P and just export it to PDF as you normally export web browser pages into a PDF. And it's going to export beautifully, just like a normal PowerPoint slide deck, believe me. And also, as for speaker notes, you can press S key. I do not have speaker notes for this deck because I have rehearsed it multiple times. I didn't need speaker notes for this. But if you require speaker notes, you can have them at the press of a button. And you will have a separate kind of page opened where you will have your tweakable speaker notes. The speaker notes themselves are added as aside elements inside the aside tag inside the slide itself. So you keep your speaker notes and the slides not separately, but in the same kind of block of HTML.
Okay. Yeah, that sounds amazing. Yeah, thank you very much, Alex, for your presentation and for this project. Yeah, it's really great. Yeah. So thank you very much, everyone, for joining us today. Please leave your feedback on the link on the talk page. Link is available in description. So you also will be available to download the PDF of this nice presentation and watch the recording. So also, if you like this presentation, maybe you don't like, yeah, please rate this talk on the talk page, and also please give Alex a badge. Thank you, badge, for his work. Yeah, thank you very much. Yeah, have a great day. Bye.
Thank you. Have a nice day.